So let's also take a look now at different ways that we can make decisions. We can make decisions using heuristics, we can make decisions using algorithms. We do these all the time. We're just really labeling things that we are already doing, what you might call a rule of thumb. When we approach a problem with an approach that's based more on a habit or a pattern or a best guess. Maybe I'm going to try what worked last time, right? So maybe last time that I encountered a problem with my computer, I did a couple of things and then that fixed it. So then maybe I'm going to try the same thing. So I'm going to try what worked last time. I don't really know why that worked. I don't really necessarily know under what conditions it would work and what it wouldn't. Another example of a heuristic is, didn't I just hear something about that? So something that you may have heard recently, may have learned about recently, you might apply to a decision that you're about to make right now. If you just heard something about, someone telling you about something that they're doing with baking to make their breads come out really good, you might try that. That would be a heuristic. And another example is, maybe it's like this other thing I'm familiar with. So you apply an approach that you are familiar with and that works in that context to a new context. So if you have learned how to get along with a very difficult person at work by just smiling and limiting your contact with them, you might try to do the same thing with maybe a fellow student that you're having to be in a group with, or maybe a neighbor that you're having to maybe come into contact with, or a family member. So you just learn, like, okay, this approach works with this person who's a little bit difficult. It just avoids conflict. I just smile and nod my head, and then I move on and keep my distance as much as possible. In contrast, an algorithm would be one that is much more analytical. Algorithm would be, for example, using a formula. Like if I want to figure out the area of a room so that I know how much carpet to buy, I can definitely use a formula. Another example is using formal rules of logic as well. That would be another example of an algorithm. So, looking to see, is this a good deduction to be making in this case, and so on. Now, when we talk about heuristics, there are certain heuristics that humans rely on a lot. And here we can see these three: representativeness, availability, and then anchoring and adjustment. Representativeness, a shortcut to help you remember this, is really the word stereotype. And I don't mean stereotype in a derogatory way, but just like the image or the typical person or item that comes up. The problem is that there are times that we should be using a formula. There are times we have the ability to use an algorithm to come up with the correct answer, but instead we're going to use this representativeness heuristic. An example is when we are judging the likelihood of an event. The likelihood of an event is something that we can determine through probabilities. And I know you've all had statistics, so I know you've all done lots of probabilities, right? What's the likelihood if you're tossing a coin that you're going to get 3 heads in a row? Well, we can calculate that. That's a math problem, right? If it's a problem that we know we can solve using probabilities, using math essentially, we don't want to guess using a heuristic. And that's essentially what happens sometimes with this representativeness. We have the ability to use an algorithm and come up with a precise answer using probability, but instead we rely on this representativeness heuristic. I have here this picture of Kahneman and Tversky. They were 2 economists who started working on decision-making problems, and they came up with these interesting examples of how humans are not very rational decision makers sometimes. And the reason that this came up in economics is, if you had a class in economics, you know that economics, the foundation assumes that humans make economic decisions in a rational way. Well, not as psychologists, we know that that's not the case, right? So here's an example of how Kahneman and Tversky studied this. They provided a little narrative, this little story here. And so this little story narrative is going to probably trigger a stereotype in us. So let's take a look at this. So go ahead and read this little section here. So based on just this narrative, we don't have any numerical information at this point. And so if we have to guess how likely it is that Jack is an engineer, we're probably going to be relying on a stereotype, right? So this is representativeness. How representative is Jack of an engineer? He's generally conservative, careful, and ambitious. Spends most of his free time on his many hobbies, which include home carpentry, sailing, and mathematical puzzles, right? That's a big one. A lot of the characteristics perhaps of Jack might be consistent with your mental image of an engineer, right? With no numerical information, we would probably say, yeah, he's pretty likely to be an engineer. But what if we add numerical information? What if we actually told you the probability? And that's what they did. They divided their participants up into two groups. One group was told that out of a group of 100 people that were interviewed, 70 were engineers and 30 were lawyers. This is the engineer high group. In other words, there are more engineers in this group. Another group of participants were given the opposite set of numbers where only 30 were engineers and 70 were not. They were lawyers instead. So kind of a different mental image perhaps, right? A different stereotype might emerge from the lawyers. And then they asked their participants, okay, so how likely is it that Jack is an engineer? Well, if we're going with just our stereotype, we're going to say that Jack is super likely to be an engineer because this whole description here is very thick with stereotypes of an engineer. But remember, at heart, this is really a probability problem. Why? There are 100 people, and out of that 100, you are being given the likelihood that Jack is an engineer. In the first group, the engineer high group, well, it's 70% certain that he's an engineer. In the engineer low group, it's 30% certain that he's an engineer. We have the probability, but we don't use it. When people are asked to figure out, hey, so here's this information, there are 100 people, 70 are engineers, 30 are lawyers, or 30 were engineers and 70 were lawyers, and then you read the story about Jack and you read that information, that stereotype is so powerful that basically it didn't matter which group they were in. Both groups rated the likelihood that Jack is an engineer to be greater than 90%. We are relying on our heuristic, this representativeness heuristic, to come up with this answer. It is not based on any numbers. So it is definitely not based on the proportion of engineers versus lawyers. And instead, we are throwing away that information and we're purely using our representativeness heuristic. We're just relying on that heuristic to come up with the answer. So participants appear to have based their judgment solely on how representative the profile of Jack was, basically ignoring the proportion. We ignore the numerical information. We don't like those numbers, do we? Just a term here, base rate. The proportion of engineers and lawyers, that's the base rate. And so here we can see that this is the base rate for this group, 70 engineers out of 100. And this is the base rate for the engineer low group, 30 out of 100 were engineers.